In this video, I'll be solving certain problems related to theory of structures and strength of material that appeared in the past paper of the competitive examination for the post of Assistant Engineer Civil. This examination was held in the month of March and in the previous year 2019, and in this video I'll be solving question number 4 and question number 6b. Furthermore, in the upcoming week, I'll be solving different past papers related to this examination. Let us start with question number 4. So the question number 4 says that a load of 210 kip is applied to a 20-foot long rod. So let's denote the load by P, and it's equal to 210 kip. And the length of the rod is 20 feet. And it has a diameter of 2.25. So the original diameter of the rod is 2.25 inches. The rod stretches 0.42 inch. Let me draw a figure for this question. So I have a 20 feet long rod and it has a diameter of 2.25 inches. So the rod stretches 0.42 inch. It means that the deformation in the longitudinal direction, that is, since the rod stretches or elongates, the nature of the load applied to it will be of tensile in nature. So 210 is basically stretching this rod. And it says that the diameter decreases by 0.001 inch. And the diameter is basically decreasing. And by how much? 2.25 minus 0.001, and the new diameter becomes 2.249 inches. So this is equal to 2.249 inches. Now why is this happening? That the increase in the longitudinal or lengthwise direction causes the contraction or reduction in cross-section wise dimension. It happens because of the phenomenon called Poisson effect. To understand Poisson effect, let us consider an elastic material such as rubber. And if I apply a compressive axial load to it, what would happen? It would obviously shrink in this dimension, that is lengthwise dimension. And when it shrinks, it causes expansion in lateral direction. That is, it kind of bulges out in the middle. Now this happens because of the Poisson effect. And the Poisson ratio is something associated with the Poisson effect. So it says that determine the Poisson ratio and the elastic modulus for the material. And let's denote Poisson ratio by mu. And we also have to determine modulus of elasticity. To determine mu, we are going to use mu is equal to minus lateral strain upon longitudinal strain. And this negative sign here indicates that if lateral strain is increasing, longitudinal strain will decrease, and vice versa. And to calculate modulus of elasticity is basically the ratio between stress upon strain, but here we are going to use the relation delta equals to PL over AE. And let's write the remaining given data. So we have this longitudinal strain equal to 0.42 inches, and this is the delta in lateral direction, and it's equal to 0.001 inches. Okay, now we are going to start with our solution. So first we are going to determine this modulus of elasticity, that is E. To determine E, we are going to use this formula, that is delta in longitudinal direction is equal to PL over AE. So sigma longitudinal is given as 0.42. So 0.42 inch, and P is equal to 210 kip, and L is equal to 20 feet. So we need to convert it into inches. To do that, just multiply it by 12 and it's equal to 240 inches. and A is equal to the area of the cross section of the bar, which can be calculated is equal to pi upon 4 multiplied by d square, and d is the original diameter multiplied by E. And if I take E to the other side and substitute d here equal to 2.25, and if you solve it, E is coming out to be equal to 30180.49 ksi, or kip per inch square. Okay, now let's determine this mu, that is the Poisson ratio. So the Poisson ratio is given as the ratio of lateral strain upon longitudinal strain, and we know that strain is change in length upon original length. So the lateral strain is going to be change in diameter divided by original diameter, whereas longitudinal strain is going to be change in length divided by the original length. Okay, so let's first try to calculate lateral strain. Lateral strain is equal to change in diameter divided by original diameter. And the change in diameter is nothing but the deformation that is occurring in lateral direction. This is equal to, change in diameter is equal to minus 0.001. The minus sign here indicates that the diameter is decreasing, and the original diameter is equal to 2.25 inches, and if you calculate it, is equal to minus 4.44 raised to the power minus 4. Okay, now let's calculate the longitudinal strain. Is equal to change in length upon original length, and change in length is equal to the deformation that is occurring or happening in longitudinal direction, which is equal to 0.42 inch, and the original length is basically the length given in the start, that is L equals to 240 inches. Remember to keep unit consistent, otherwise you will get the wrong answer. So if you divide it, it's coming out to be equal to 1.75 raised to the power minus 3. After calculating these strains, substitute these strains into this formula. So mu from here is equal to minus, the lateral strain is equal to minus 4.44 raised to the power minus 4 divided by the longitudinal strain, and longitudinal strain is equal to 1.75 raised to the power minus 3. So mu from here is equal to 0.253. And we're done with the first question. Okay, now the second question, question number 6b, says that a steel bar 3 meter long. So L here is equal to 3 meter, and area here is equal to 2500 millimeter square. It hangs vertically. So if I draw a diagram, it would look something like this. So I have a rod which has a length of 3 meter, and it has a securely fixed collar on its lower end. So let's draw the collar with a different color. And if a weight of 15 kilonewton falls on a collar from a height of 10 millimeter, determine the stress developed in bar. So we are asked to determine sigma, that is the stress developed because of the load, 15 kilonewton load, that is going to fall suddenly on this collar. So they are asking us to determine the stress induced in the bar when this load falls on this collar from a height of 10 millimeter, and let's denote this height by h. So h is equal to 10 millimeter. So this question over here is basically a case of stress induced in the bar due to impact loading or sudden loading. we can see here that this weight, 15 kilonewton weight, is dropped from a height of 10 millimeter on a collar suddenly, and we have an expression which can be used to calculate stress induced in a bar due to sudden loading, and it's equal to P upon A bracket 1 plus root 1 plus 2AEH upon PL. So we have P equals to 15 kilonewton, and A is the area of the bar, E is the modulus of elasticity, and H is the height through which the weight has fallen, and P again is the load, and L is the length of the member. Now what would be the value of E? Now you might say that it's not given in the question, but we know that it's a steel bar, so the examiner is kind of expecting you to know that E of steel is equal to 200 GPa, that is gigapascal. This question is simply a case of putting values in a formula, that's it. Before substituting these values into this formula, we need to keep the unit consistent. So I'm going to keep the unit in terms of Newton and millimeter. So convert this length, meter length, into millimeter. This would be 3000 millimeter, and this kilonewton into Newton, just multiply it by 1000 and you'll get the Newton value. And we need to convert this E into from gigapascal to Newton per millimeter square. We have E equals to 200 gigapascal, and we know that gigapascal is equal to 10 raised to the power 9, and Pascal on the other hand is equal to Newton per meter square. 1 Pascal is basically equal to 1 Newton per meter square. And if you want to convert now to convert it into Newton per millimeter square, we know that 1 meter is equal to 1000 millimeter, right? So take the square of it and simplify it, and there you have it. So, and H is in millimeters, so we don't need to convert it. Okay, let's start with the calculation. So substitute all of the values. And if you solve this, it's coming out to be 95.64 Newton per millimeter square. And that's your answer. And we're done. Thanks for watching till the end.